Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwane. I hope you know me well now. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Okay, grade 12. Our topic for today is differential calculus. We are now moving to part 3. And then on this part 3, our objective of today's lessons are after the completion of the lesson, you must be able to apply the remainder and factor theorem to polynomials of the third degree. Secondly, you must be able to factorize and solve cubic equations. Lastly, you must be able to sketch the graph of a cubic polynomial function. All right, without any waste of time, grade 12, let's start with our first example of the day. So our first question is determine the remainder when f at x is equal to x cubed minus 3x squared plus 5x minus 9 is divided by what now? By x minus 1. And then what is our starting point now? We are going to use those notation where you are substituting an x with a certain value. And then now we are now relying on what? On our divisor, which is x minus 1. So what we are actually going to do is that we take this divisor x minus 1 and then we let it equal to 0. So we will end up with x equals to 1. So the x equal to 1 is the one that we are going to substitute into our f at x so that we can determine what? The remainder of that f at x function. All right, grade 12. Let's do so. Where we are having an x, we are now going to substitute with a what? With a 1. So there we go. We take our f at x function, which is equal to the x cubed minus 3x squared plus the 5x minus 9. Where we have an x, we do what? We now substitute with the 1. So we are going to have f at 1, x substitute by 1, cubed minus 3. Where we have an x, substitute a 1, squared plus 5. Where we have an x, we substitute with the 1 minus 9. And then now, after substituting this divisor x equals to 1, this is now our remainder. This f at 1 is now representing what? Our remainder for that particular what? Function. And then now grade 12, after substituting, avoid partial simplification. You have your Casio, your sharp calculator. It can accommodate everything with brackets. So after substituting, please put everything into your calculator. So we are expected to have our answer as what? Grade 12 minus 6. I hope we are still together on that one. Okay, without any waste of time, I don't want to say many things to you that will confuse you. I want you to do your own activity now. Okay, this is your activity, grade 12. We are only going to spend 2 minutes doing that. Check a remainder for me, and then after 2 minutes, we will be reflecting back. Your 2 minutes starts now. Okay, grade 12s. Let's check now how far did you go with the solution. Remember, our WhatsApp number is 0636293655. It is also indicated at the bottom of your screen. You can send your solution also via that, and then you can also ask for clarity, any question based on today's topics. Thank you on that one. Okay, let's go back now to our activity. You were given that you need to determine the remainder of f at x, that is your function, if your divisor is now x minus 2. This is now divided by x minus 2. Remember, initially we said you let this equal to 0, so you'll end up with the x which is equals to a 2. That x equals to 2 is the one that we are going to substitute grade 12. I hope we are still together on that one. We are now substituting in our f at x function. Where we have an x, we are going to substitute that with a 2. So that is f into 2. And then for x cubed, we are going to put 2 cubed. And then plus a 2 from our equation there. For x, we are substituting a 2 that is squared. And then we have a plus 1. Remember, I've indicated that the minute we have substituted f at a certain value, this is now representing what? The remainder. And then grade 12 into your calculator. I hope every one of us have got the answer equal to 17. So that means the remainder for this particular question is r equals to 17. Thank you very much on that one. Hope we are still together. Moving forward, grade 12. Right, let's look at the second example now. We are given when 2x cubed plus mx plus 3 is divided again by x minus 1. We are now given the remainder which is equal to 2. Look at that problem now. It is now different from the previous one. And then we are expected to determine the value of m. What is different from this question compared to the previous one is that this one is now having an extra variable, which is m. And we are expected to determine the value of that particular variable. Okay, same method, grade 12. Remember, this will be representing our expression, our equation, which is f at x, and then this is our divisor, but in this case we are given the remainder which is equals to 2. The same method, remember previously we were taking the f at x function. 2x cubed is now our f at x plus mx plus 3. And then now we look for the divisor which is x minus 1. And then we let it equal to 0 so that we can have the x equals to 1. So x equal to 1 is what we are going to substitute into our f at x function. So where we have x, we are now substituting with the 1. And then we have 2 into 1 cubed plus m, x you are 1, and then plus 3. And remember, previously we indicated after substituting f at a certain value, we are now looking at the remainder of that particular function. So now, on the left-hand side, what we are having actually is the remainder, as we did previously. Then this is 2 into 1 cubed, which will end up giving us just the 2. And then m times 1, which is m, and then a plus 3. But grade 12, remember the remainder is given to you now in this case, which is equals to what? A 2. So where we are having remainder on our left-hand side, Okay, grade 12, let's check how far did you go with this one. Keep on marking yourself and check how many marks can you get for today. All right. And then now let's check. Calculate the value of P is your expected variable to answer there. And then you have your f at x equation. You have your divisor, which is x minus 1. You are also given a remainder, which is equals to 3. The method is still the same, grade 12. I hope we are still together. Remember, you start by dealing with the x value there. So you'll end up with x equals to 1. And then now substitute that in your f at x function. Our f at x function is equal to x cubed plus px squared minus x minus 3. Where we are having an x now, we are going to substitute with the 1. And then that is 1 cubed plus p. X, we are substituting a 1. Take care of those exponents, grade 12. Ensure that all your exponents are indicated after substitution. Double check. Okay. Again, x is 1 and then a minus 3. Remember that the minute you have substituted f at x with a something on x there, this is now a remainder, f at a certain value. And then now we can now simplify your right hand side. 1 cubed is 1 plus the 1 squared is 1 times p, which is p. And then we have a minus 1 and the minus 3. And then what is your remainder? Remember, the remainder is given to you as remainder is equals to 3. So for r, we are going to put a 3 there, the value of the remainder, which is equal to this side. We can now start adding like terms. It's 1 minus 1, which is a 0. So we are left with only p minus 3 on the right-hand side. So we are solving for p. We are going to transpose a minus 3 to the left-hand side. Therefore, p is equals to what now? A 3. This minus 3 to that side, it will be a positive 3. Therefore, p is equals to what? Equals to 6, grade 12. I hope all of us, we are at that level. Remember, our WhatsApp number, 063 629 3655. It is also indicated on your screen there. All right, going forward now, we are done with the remainder theorem. We now move on to the factor theorem. And let's see now what is the difference between the two. Remember, if we talk of a factor of a number, when you divide, for an example, let's say we are given a 4. And then we know that factors of 4 are 1, 2, and 4 itself. Those are the only factors. And then what do we mean by saying it's a factor? When we divide this particular 4 with a 1, can you see that this goes 4 times? Do you have a remainder? No, your remainder will always be a 0. Check now. Take a second factor. 4 is divided by 2. This is giving you a 2. Do you have a remainder? No. Always the remainder will be equal to 0 there. And then you are given 4 divided by the last factor equal to 4 equals to 1. Okay, 4 divided by 4 is 1. Remainder, 0. So the minute we say we are dealing with the factor theorem, we are expecting the remainder to be a 0 on that particular condition. Let's see now. Look at the first example, the grade 12. Prove that x minus 3 is a factor of f at x equal to x cubed minus 5x squared plus 7x minus 3. The application, it is somehow the same as we were doing with the remainder theorem. We now take our f at x function, yes. In this case, we are going to use the factor x minus 3, which we are proving it's a factor now. X minus 3, we let it equal to 0. And then now we'll be having x equals to 3. Remember, this is not yet a factor until it is proven a factor. How do we know it will be a factor? If the remainder is what? A 0. It is only then that we can say, yes, this is a factor of that particular f at x. All right, grade 12, let's do so now. We take our f at x function. Yes, f at x is equal to x cubed minus 5x squared. And then the plus 7x minus a 3. And then we are substituting our x with what? With x equals to 3 now. Wherever I'm having an x, I am now putting a 3. This will be 3 cubed minus 5 into 3 squared plus a 7 into 3, and then a minus 3. Okay, remember previously we indicated that if you substitute f at a certain value, then this is representing a remainder, all right? And then let's follow that also grade 12. And then remember, after substituting, we put everything into what? Into our calculator. And then this whole thing will now give us a 0 there. Can you see now our remainder is 0? And then we have indicated that if we are having factors, your remainder will always be 0. This is now simply telling us what? The x minus 3 that was initially given to us. X minus 3 is a factor of that particular f at x function. Therefore, x minus 3 is a factor. How do we know? The remainder is 0. Okay, let's check. Can you do it on your own, grade 12? 2 minutes, your time starting now. Okay, grade 12s, let's check how far did you go with this one. Okay, number 1, remember you are looking for that x minus 1 or x plus something. But in this case, be careful. Your x is given to you there because it is substituted with the 2. So this is actually x equals to 2, correct? That simply means this was initially what? An x minus 2 equals to a 0. It started there, goes to x equal to 2, and then it is now substituted in your f at x function. So yours is just to take that 2 into the function f at x. This is our f at x function. We are now going to substitute the x with the what? With the 2. Okay, so we are having f at 2, which is equal to 2 to the power 3, minus 2x, you are 2 to the power 2, minus 4x, again 2, and then a plus 8. All right, remember f at a certain value is a remainder. Okay, this is equal to putting everything into your calculators, grade 12, and then this is giving us what? A 0. Therefore, we have shown what? That f at 2 is equal to a 0. This simply means what? The x minus 2 is a factor of that particular f at x. And then another mistake that you do, grade 12, is that if it is a positive 2 then, when you take it back to its factor, it must be opposite sign, x minus 2. Okay, if it was a minus 2, it will be an x plus 2 in the factor though. So to be very much careful around mixing those signs around. Okay, moving forward. Right. Now let's look at the next example there. We are given f at x is equals to 2x cubed minus 5x minus 4x plus 3 as our f at x function. The first question states that show that 2x minus 1 is the factor of that particular function. Grade 12, you are now familiar with that one. We've done that on the previous questions. So if you are showing it's a factor, we are expecting our remainder to be a what? A 0. Okay, and then let's address the 4.1 before we go 4.2. Right, 4.1. We are showing that 2x minus 1 is a factor. Remember, you need an x value that you are going to substitute in your f at x to check that the remainder is 0. So in this case, we are given 2x minus 1. We let this equal to 0, and this will be 2x equals to 1. And therefore, x is equals to what? 1 over 2. That will be the x that will be substituted into what? The f at x function. Okay, then we have f at x equals to 2x cubed minus 5x squared minus 4x plus 3. We are now substituting f into x is now a half equals to 2x half cubed minus 5 x half squared minus 4 x half and then the plus 3. Be careful, check your exponents. Are they presented correctly before you continue? And then remember, this side is now the remainder, grade 12. And then now this remainder, put everything into your calculator, and therefore you'll end up with what? With the 0. This shows what now? That the 2x minus 1 is a factor. Okay. And then hence or otherwise, determine the x-intercept of f. If f at x is equal to what now? 2x minus 1 into x squared minus 2x minus 3. So basically, grade 12 now, they have factorized this function for you. As you can see that you are having the same factor that we indicated is the first factor as our first factor there. They have already determined the trinomial thereof. Yours is to complete the remaining part. Okay, now to find the x-intercept, remember mathematically throughout, you let what? Y equals to 0. We are going to follow the same method. We are taking what now? Our 2x minus 1 into that trinomial x squared minus 2x minus 3. This is equals to a 0 because we are looking for what? For the x-intercept. We let y equals to a 0. Now, let's factorize the trinomial now, grade 12. Check what are the factors for that. This trinomial is now indicating to us we are looking for the factors of 3. When you subtract them, they must give you a minus 2. Okay? Factors of 3, when you subtract, you get a minus 2. Those factors should be what? A 3 and a 1. Okay? And then now to get a minus 2, the bigger number must take a negative sign, minus 3. And then we have a plus 1 there. Therefore, grade 12, our first x value, remember this one is the same as that one. We can just conclude it will be x equal to a half. The second bracket will give us what? An x equals to 3. The last bracket will give us what? An x equals to minus 1. That is basically what we were looking for in terms of the x-intercept. Okay, I hope we are still together, grade 12. I don't want to continue alone. I want you behind my back. So the next activity, it will be yours. And check whether can you do the same application. Okay, let's take 5 minutes on that one because we are having 2 questions. Your 5 minutes starts now. Remember your WhatsApp group 0636293655. You can send your questions and solutions to that platform. Thank you. Starting now. Okay, grade 12. Let's see now how far did it go. All right, we are given our f at x is equal to 2x cubed minus x squared minus 18x plus 9. But remember, you need that value of x that you are going to substitute into your expression. And then the first question states that show that x minus 3 is a factor of that. There you are. You have the x minus 3. We let it equal to 0. So we end up with x equals to 3. Therefore, we know that now where we are having an x, we are going to substitute with a 3. Okay, let's take our f at x function. 2x cubed minus x squared minus 18x plus a 9. And then for x, we are now substituting x with the 3. And then we have 2, x is 3, cubed minus x is 3, squared minus 18, and then the x is 3, plus a 9. Okay, remember we are checking whether is it a factor now. To be a factor, you check your remainder, and then grade 12, if you put everything on the right into your calculator, this will give you a 0. And then since the remainder is 0, therefore, x minus 3 is a factor of that f at x function. Okay, and then question 4.2. Hence or otherwise, determine the x-intercept of f at x. You are not that lucky enough. Look at that, they didn't factorize for you. To check the trinomial, you must do it on your own. We are having different ways of doing it, grade 12, but I am going to do the shorter method. Remember, we have the short method, we have synthetic division, we have the long division method. And then now, how do we do that? Remember, if we are looking at the x-intercept, you let what? Y equals to 0. So our function is 2x cubed minus x squared minus 18x plus 9. And then we let this equal to a 0 because we are looking for the x-intercept. We already have our first factor, which is x minus 3. And then we are looking for the trinomial factor now, which will be equals to a 0 now. The short method that we will be applying grade 12, we are taking the 2x cubed divided by x. That will be the 2x cubed first term to first term of the first factor divided by x. Then that will give us then 2x squared. So that will be the first term for your trinomial there, 2x squared. And then the last term of your f at x divided by the last term of your factor there. So that will be a 9 divided by minus 3. That will give you what? A minus 3. And then this will give us the last factor for a trinomial there. You can even multiply back x times 2x squared. It must give you a 2x cubed there. And then minus 3 times a minus 3, it must give you a 9. If those two are correct, you are now remaining with the middle term. We let that be bx because we don't know the actual value of the middle value there. So that is our challenge now. We need to calculate the value of that b. Right, how do you do that, grade 12, with the short method now? We are going to multiply these two here, minus 3 and positive 2x squared. Then it will give us what? A minus 6x squared. Let's do it on the side here. Minus 6x squared. Multiply x with the middle term there. So this gives us a bx squared. That is all we need, grade 12. Only those two. And then we are going to equalize it to the x squared. That is in your original function. And then you can see that this is a minus x squared. Okay, with this now we can now determine the value of b, grade 12. That is the shortest method that you can apply. And then it is avoiding so many mistakes that we do of negative signs, wrong additions in long divisions, and so on. So now we are having leave bx squared this side. And then we are going to transpose a minus 6x squared to that right-hand side. And then a minus 6 to this side, it will become a positive 6x squared. Then positive 6 minus 1x squared, this will give us a 5x squared. Basically, grade 12, therefore, our b is equal to 5. So now we have our complete trinomial factor now. It's x minus 3. Then the trinomial bracket is 2x squared. How much is the b value? Positive 5x minus 3 equal to a 0. Then you have now your trinomial factor, grade 12. You can now easily factorize that. You have x minus 3, and then this will give you 2 brackets. You can also use your quadratic formula, because now you are having a trinomial of to the power 2. You are also welcome to use your quadratic formula, grade 12. And then this is 2x. Factors of 2x squared is 2x and x. Okay. Factors of 3, when you subtract, give you a 5. But remember, 2 is having a contribution in one of the factors there. Okay. So you must be careful when you write your 1 and 3. And then we put a 1 there, put a 3 there. Can you see that this 2 will give you a 6, and then this one will give you a 1. So you are having a 6 and a 1 there. So to get a plus 5, that means this bigger one must be positive. Where did it come from, plus 6? It comes from multiplying a 2x and a 3. Therefore, positive must go to that side. So now we are having a negative 1 there. Okay, so we have our factors now, grade 12. We can now solve for x. And then the first bracket will give us an x equal to 3. Or the second bracket will give us an x which is equal to 1 over 2. Or the last bracket will give us an x that is equal to what? A negative 3, grade 12. I hope we are still together on that one. Moving forward, we are still on factor theorem. We are now solving for x. Remember, we need these x values when we want to sketch our cubic function, where we'll be solving for x-intercept of that particular function. We are now going to do it thoroughly now, grade 12, with you, so that you don't have a challenge when coming to calculating the x-intercept of a cubic function. Number 1, we are solving for x for which function? We have x cubed plus 3x squared minus 10x equal to 0 then. If you look at this cubic function, first thing that you need to do in all your equations, grade 12, before you can do anything, check, do you have a common factor before applying anything? All right. And then if you look at this, you can see that we have a common x there. So we are going to take out that x as being common factor. And then if I take x out here, I'm left with x squared. Okay. Plus 3, I'm taking 1x out, I'm left with 1x. Okay, minus 10, I take out an x, no x is left anymore for the third value then. So this is still equals to 0. Okay, so we end up with a quadratic equation now then, grade 12. So application of factorizing quadratics, it's very important in the intercept of a cubic function. So now we are having an x. Continue with factorizing that trinomial. You can also use your quadratic equation. You are more than welcome. Quadratic formula, grade 12. And then we are looking at the factor of x squared, which will be x and x. Now we need factors of 10. When you subtract, they give you a positive 3. Okay. And now grade 12. Which values are factors of 10? Factors of 10 are 1, 2, 5, and 10. And then if we now combine the products that give you a 10, we have 1 times 10, which is equal to a 10. We have a 2 times 5, which is equal to a 10. And then now you don't just write any factors that you want, grade 12s. You listen to the trinomial. It is talking to you. What is it saying? It says take factors of 10. When you subtract them, they give you a 3. Okay? Can you take 10 and 1? No. When you subtract 10 and 1, you get a 9. Okay? Let's test the second one. Can I take 5 and 2? Yes, because when I subtract 5 and 2, I get a 3. But now my 3 must be positive. So now when looking at 2 and 5, which one must be positive so that you get a positive 3? 5 must be positive, and then the 2 will take a negative. Then 5 minus 2 will give you a 3, and then when you multiply, then they will give you what? A negative 10. Basically, after testing grade 12, you can now put your factors into your bracket. That is a plus 5 and a minus 2. In whichever way, you can say minus 2 and a plus 5. It doesn't matter. It's the same thing. Now we can now give the actual values of x. So our first x here is x equal to 0, or the x is equals to minus 5 for the second bracket, or an x that is equals to a 2. Basically, grade 12, those are the expected values of x. Now, the misconception done by most learners, they take this expression, x cubed plus 3x squared minus 10x equal to 0. They will start by dividing by x throughout, divide by x, and cancel, and then there's left with x squared, and the plus 3x cancel 1x, they're left with 3x minus 10 equal to 0. And then grade 12, compare this one to the one that we were having here. Can you see that we have lost one value there? Since it's an x cubed, you must have 3x values. But if you do it like this, you will end up with only 2x values. So one x value will be missing. Okay, it will make it very difficult for you to sketch that cubic function. So be careful of this misconception. We don't want to see these mistakes anymore. Okay, moving on to 5.2. In 5.2, one of the roots of x cubed minus x squared minus 3x plus 2 is 2. And then what do we understand by the word roots? Okay, we are talking to the x value of that particular function. When we talk roots, we talk x values of a function. So in this case now, the root is equal to 2. That means one of the x values for this function is equal to 2. It's given to us. Then they say determine the other roots. So we are going to do that first short method application with you. But in this case now, we are going to do all of them, 3 of them, followed by synthetic, followed by long division, so that you can choose the one you are comfortable with, grade 12. And then let's do so. Now, starting with this first one, we are given one factor. Remember now, if we are determining other roots, we are looking for other x values, right? And then to find the x values, remember, it's like calculating the x-intercept. You let your f at x equals to 0. So this is the function we are talking to, x cubed minus x squared minus 3x plus 2 is equals to 0. We have one factor, remember, which is x equals to 2 there. So now we can take this back. It was initially x minus 2 equal to 0. Okay, then we'll take it as being the factor for this particular, one factor for that one. So we are looking for the trinomial one. Okay, grade 12, do you still remember the method? First term of your f at x divided by first term of your factor there. That will be x cubed divided by x, which is x squared. It will give you the first factor of the trinomial. Looking at the last factor, 2 divided by minus 2 there, it will give you the last factor of your trinomial. We now need what? The middle one, which is bx. Remember, we are relying on the 2. Multiply these 2. It will give us minus 2x squared. Multiply these 2 plus bx squared equal to what? The x squared in your expression, which is minus x squared. Okay? And then now we need the bx squared. It will be equal to minus x squared. Remember, this minus 2x, when it comes to this side, it will be a positive 2x. So it will be 2x minus x, which is equal to and x squared. Okay, Positive 2x squared minus x squared is a positive x squared. This simply remember there's a coefficient there which is 1, and then this simply means our b value is equals to 1 there. Back to the trinomial, therefore this is x minus 2, and then we have an x squared plus x minus 1 equals to a 0 there. Okay, grade 12. And then if you look at this now, we are looking for factors of 1. When you subtract, they give you a 1. Is it possible, grade 12, to have factors of 1? Because factors of 1 are only 1 and 1. So can you subtract 1 and 1 and get a 0? A 1? No. 1 and 1, when you subtract, it will give you a 0. So this simply shows us that we don't have factors for this trinomial. But grade 12 at your level, you know what to do. When you don't have factor, you go for quadratic formula. So let's do so now. Only for this trinomial, ne? Because for this first bracket, we do have a value of x, which is x equal to 2. Our focus will be on this one, using the quadratic formula, because this bracket is x to the power 2. So now, go quadratic, x is equal to minus b. What is our b? B is 1. Remember, A is also 1, and the C is minus 1. So that will be minus B, which is 1, plus minus the square root. You are now more familiar with this grade 12. We'll be using this more often. And then B is 1 minus 4. The A value is 1. The C value minus 1. And then everything 2 into a 1. And then what do we get now in a simple set form? It gives us minus 1 plus the square root of 5, everything over 2. And then now, remember grade 12, we can now press that SD button. It will give you the decimal solution for your x values. And then round it off to second decimal unless stated otherwise. And then the first x value here will be equal to 0.62, or the second one will be minus 1.62 rounded off to the second decimal, grade 12. I hope we are still together on that one. Okay, let's take another example. Remember, this was the short method of doing this. Ne? Keep in mind your trinomial factor, which is x squared plus x minus 1. And your first factor, which is x minus 2. We are now going to apply the synthetic division method and see now, can we get the same trinomial factor? Okay, moving forward to synthetic division, grade 12. Right, we have one of the roots is the same question, which is 2. That means we are having our x equal to 2, which was initially x minus 2, which was led to be 0, and then determine the other roots of this particular f at x function. And then how do we do that, grade 12? All right, we are looking at the coefficients. When we are talking synthetic, we are relying mostly on the coefficients of your expression. And then you must ensure that, number 1, your function is in descending order, starting with the x to the power 3, and then the x squared, the x to the power 1, and then the constant value. After that verification is then that, grade 12, you can take your coefficient. And then the coefficient of x cubed is 1, and then we are having a minus 1 there for x squared. We have minus 3, and then we have a 2. Synthetic division is relying on those coefficient values, right? Let's take our table then. And then we take the first coefficient of x cubed. It will be the x cubed, x squared, the x, and the constant value there. That means it will be 1 there. And then the coefficient of x squared, minus 1. Coefficient of x, minus 3. The constant value is positive 2. Right. And then now remember our divisor. Now our factor is x minus 2, which is x equals to 2. X equals to 2. All right. And then now let's draw another line there, grade 12. Okay, now first method is you bring down the first coefficient as it is. That means it will be 1 there. So the next step, you are multiplying now the two 2 times 1, it will give us a 2. It is now a multiplication, all right? 2 times 1 is giving us a 2. The answer that you get there, you put it beneath the next value there. And then from there, you will be adding these 2. Minus 1 plus 2. That will give you a positive 1. The minute you have a value below there, you start multiplying again. 2 times a positive 1. That will give you a positive 2. Below the next 10, and then you are adding the 2. That is minus 3 plus 2, which is minus 1. The minute you have something there, you start multiplying again. 2 times negative 1, which is negative 2. And then you add the 2. 2 minus 2, which is a 0. And then why is it giving us a 0, grade 12s? Is because this part is what? A remainder. It is showing that 2, it's a x minus 2, it's a factor of that particular function. If you are in a factor theorem where you are looking for x-intercept, you must always have a 0 remainder there at the last point. And then now, what do we have now? Remember, you have that 2 there. Where does it come from? From a factor x minus 2. And then now we were looking for the trinomial factor now. And then grade 12 below here, what you have now is an x squared, the x, and the constant value. And then what is our x squared? It's 1x squared. The second one, positive 1x. And then the last one, constant value, minus 1. Can you see now we end up with the same trinomial that we were having previously, and from there you follow the same method, quadratic formula, because we do not have factors of 1. When you subtract, gives you a 1. 1 and 1 when you subtract gives you a 0. So this is how you do synthetic grade 12. Choose the one that is suitable or you are comfortable with. And then the long division method now, that is the last third method that you will be applying. Okay, we are still having the x minus 2 as being our factor there because it's one root, therefore it is automatically a factor of that function. So with the long division, grade 12, I know with this one, you are making so many mistakes, grade 12. If I were you, I will avoid this method as far as possible, okay? But I don't want to choose for you. You can select from the 3, the one that you are comfortable with. And then below this notation, you put in your f at x function, that is x cubed minus x squared minus 3x plus 2. Remember, checking your descending order of exponents is very important. All exponents must appear there, starting from the highest 3. 3 is there, 2 and 1. And then with the constant 1. Okay. Right, let's start now. The division method, remember, it says divide. After dividing, you multiply back. After multiplying back, you change sign of the below part. And then you can now add. Okay, let's do so, grade 12. When you divide, you only divide with the first term there. That will be x into x cubed. Then this is giving us an x squared. Okay, only with the first term. But when you multiply back, you multiply into both of them. So now that is the first step. Second step there, multiply back. It will be x times x squared times x, which is x cubed. And the x squared times minus 2 minus x squared. And then change the sign for the below part. That means this x cubed is positive. It will now change to negative. And then the minus 2 is negative. It will now change to positive. And then add only these two parts, okay? And then that will be x cubed minus x cubed. That will give us a 0, or it will cancel off. And then we are having a minus 1x squared there. And then we are now using the new sign, which is positive 2. It will be a minus 1 plus 2, which is 1x squared. No harm in writing that, grade 12. And then the next step, now after adding, you bring down the next term. Only one term down, all right? Then this will be minus 3x. After bringing down, you start again, you divide, okay? We divide only with x, remember, in only the first term, and then this will be x into x squared here, which will give us a positive x. But when you multiply back, you multiply in both. X times x, x squared. X times minus 2, minus 2x. Change sign below terms, minus, and then this one will be a plus. And then a 1 minus 1, it's a 0, cancelled. And then a minus 3 plus 2, it's a minus 1x. After adding, you bring down the next term. We are now bringing down plus 2. After bringing down, you start again the method divide only in the first term, first to first, okay? X into minus x is minus 1. When you multiply in both. Minus 1 times x minus x. Minus 1 times minus 2, it's a positive 2. Change sign below, minus is now becoming positive. Positive, it becomes negative. A minus 1 plus 1, 0. A plus 2 minus 2, 0. Can you see now the remainder is 0 there? Okay, that means we are 100% correct, grade 12. That is your first factor, x minus 2. And then your trinomial factor is what you are having above there, which is x squared plus x minus 1. Can we see, grade 12, you still end up with the same trinomial factor with all three methods. But remember, you don't have the factors for that. You still have to use what? A quadratic formula to find the remaining factors there. Quadratic formula, grade 12, if you can't factorize. All right. And then the 5.3, let's look at this again, grade 12. With this one, if you look at the exponents now, it's different from the previous one. We are having x cubed, x squared is missing there, and then it's now an x and a 4. Hence, we brought this to your attention, grade 12. Right, in case where there is a missing exponent, remember I've indicated that your exponent must all be presented in descending order, starting from the highest. We want to see an x cubed, x squared, x, and then a constant value. If, like in this case, the x squared is not presented, we are going to squeeze that in. How do we do that? We change this one is x cubed. Yes, it is there. X squared is missing there. We will add that as a 0x squared. No harm, grade 12. And then we can bring down the minus 6x, the plus 4, and the equal to 0. Therefore, we have our expression now. But now, this is not easy at all. We are not given any factor now. Nothing is given to us, grade 12. You need to test which one will be the factor. Which one will be the factor, okay? Right, so to check a factor, we substitute 1 minus 1, 2 minus 2, 3 minus 3, until you find a 0. Remember, the minute it gives you a 0, it shows that this is a factor now. Okay, now how do we do that? We take this f at x cubed now minus 6x plus 4. We are testing factors. You substitute 1 minus 1, 2 minus 2, and so on, grade 12s. And then if you substituted 2 now, let's see what happens when you put a 2 there, and then plus 4. And then this will be a remainder. Yes, grade 12. This is the one that is giving us a 0. But remember, you'll be testing 1, testing minus 1, testing 2, minus 2, until you get the one that is giving a 0. If it gives a 0 now, it states what? X minus 2 is a factor of that particular function. Happy now. We have one factor. We can now apply our short method. I'm in love with the short method because it is avoiding so many mistakes of signs and adding and so forth. So the first factor here will be x minus 2. We are looking at the trinomial factor, grade 12. Remember, the first term will be x cubed divided by x. That will be x squared. The last term 4 divided by minus 2. That will be the minus 2. We are short of the bx, remember? So we multiply these 2 minus 2x squared. Do it aside. And then we have x and bx, that is giving bx squared, And then we take the x squared from our expression. Remember, we have added that 0x squared. Therefore, this will be 0x squared. And then now we have a bx squared equal to a 0x squared plus 2x squared. This side will give us a 2x squared. Can you see now the value of b is equal to 2? Yes, happy now. We have x minus 2, and then we have x squared. The b value is 2x with a minus 2 equal to 0. This trinomial is talking to you, grade 12s. We are looking for factors of 2. When you subtract, gives you a 2. Is that possible? The only factors of 2, remember, it's 1 times 2. Can we subtract this and get a 2? No. If that is the case, you are stuck with what? Quadratic formula, grade 12s. Therefore, for the first bracket, no stress, your x will be equal to 2. But for the trinomial, still we have to go the quadratic formula. Minus b plus minus the square root of b squared minus 4ac all over 2a. And then coefficient of x squared is your a value. And then this will be your b value. The constant will be your c value. You are now familiar with this, grade 12. You've been doing this for a very long time. B value 2 plus minus. The square root b is 2 squared minus 4. The a value is 1. The c value is minus 2. And then everything 2 into a 1. And then now, what does it give us now? When we put into our calculators, it gives us a simple set form first, which is minus 1 plus square root 3. You know what to do. Press SD button, sharp calculator, Casio. Then it will give you a minus 2,73 for the first factor. Second factor, this is giving us what? A 0,73, grade 12. So here, what were we emphasizing? The sequence of your exponent is very important. It must click 3, 2, 1. Therefore, everything is in order. And then number 2, do you have a factor now? A binomial factor that you are going to use? If not, substitute 1 minus 1, 2 minus 2 until you get what? A 0. The one that is giving you a 0 is the factor. Then you follow the same method that you were doing previously. Okay. Can we have a 2 minutes break? Stretch your legs. Thank you. Okay, grade 12s. Let's continue. You know, I'm not a preacher, ne? I've already done my part, and then I am now going to give you an activity. at least the 2 that we are having now, to check, can you do this on your own? All right. Okay, let's just change that 8 is supposed to be a 10 there. All right. We are solving for x in those 2. Okay. Your 5 minutes starts now, grade 12. Your 5 minutes start now. Okay, grade 12s. Let's check how far did you go with the first one. All right. Can you see that you are having your common x there? Remember, before you do any factorization, always check for a common factor. So we are having your common x there. And then if we divide x cubed divide by x, that will give us an x squared minus 12. And x squared divided by x, that will be x. And then for the last term, we are having 36 because x divided by x will give us a 1 equal to 0, or they cancel off. All right. And then after taking out a common factor, you now have a trinomial factor there. So that will be x. We are factorizing that trinomial. All right, we are looking at the factors of 36. Remember, your trinomial is always telling you what do I want. All right, it is saying factors of 36. When you add them, they must give you a 12. Okay, and then factors of 36 that give you a 12, grade 12, it is 6 and 6. And then they must both be what? Be negative, because we are looking for minus 12 then. Okay, if you are not comfortable grade 12, you can still use your quadratic formula to factorize. And then now the first x value here will be x equal to 0. If you look at these two brackets, they are giving us the same thing. So there's no need to repeat. You can only tell us that, oh, x is equal to a 6. There's no need to write another 6. 6 and 6 is the same thing, all right? So it's x equal to 6. But it has a certain meaning to us in terms of the x-intercept of a function. In case where you have the repetition of your factors, when you look at the x-intercept, you must know that that graph is turning at that repetition. So this x value is actually the turning point of that cubic function. You'll see that when you do the sketching of a cubic grade 12. But bear in mind, the minute you factorize, you have same factors. It simply means that x value is the x value of one of your turning points grade 12. Okay, 5.2. Let's look at 5.2 now. Okay, before we go 5.2, let's allocate marks to 5.2. We are now bringing in marks. Let's see how much can you get grade 12. All right, the first mark will be allocated for the step where you have factorized, taking out an x common, and then end up with the correct trinomial x squared minus 12 plus 36 equal to 0. That will be your first mark, grade 12. I hope you got that one. And then the second mark will be for what? For factorizing this trinomial x squared minus 12 and end up with factors x minus 6, or x minus 6 squared, because it's two brackets of x minus 6. That will be your second mark, grade 12. And then the last mark for giving us the final values of x equal to 0 or x equals to 6. So basically, this question will worth how many? 3 marks. I hope all of you got that 3 marks. Let's move on. 5.2. Look at that, grade 12. Not good at all, because you don't have any factor for that particular expression. That means we are going to use that testing, trial and error, until we get the one that is giving us what? A remainder of 0. You can do it in your calculator, substitute a 1. Okay, is it giving us a 0? Substitute a 2. Is it giving you a 0? Substitute a minus 1. Substitute a minus 2. Until grade 12, you get the one that is giving you a 0. In this case now, then if you substitute f at 1, this will be 1 cubed plus 8 into 1 squared plus 17 into 1 plus 8. When we put this into our calculator, we get an answer that is equals to a 0. That is 10, grade 12, 10 there. Okay, that is giving us a 0. Okay, x minus 1, sorry. This must be x minus 1. This one is not giving us a 0. When you substitute x with a negative 1, it is giving a 0. Anyway, if you substitute a 1, everything will be a positive answer. There's no way that it can give you a 0, grade 12, isn't it? Okay, and then now, After testing, okay, when I substitute minus 1 is now giving me 0. It simply means the remainder is 0. Then therefore x, if it is minus 1, it will be x plus 1 is a factor. I now have one factor of that expression, that is x plus 1. I am looking for a trinomial factor. Short method is a key now. X cubed divided by x, that will be x squared. We can now do this grade 12. Be careful, this is a 10. A 10 divided by 1, it's a positive 10. Looking for the bx middle term, multiply these two. We have an x squared, 1x squared, all right? And then we have x times bx, that is bx squared. The x squared term in our expression equal to 8x squared. And then the bx squared is equal to 8x squared minus x squared, that is what? 7x squared. Therefore, the b value is equal to 7. So this is giving us x plus 1. And then we have the x squared. What is b? 7x plus 10 equal to 0. There you have your trinomial factor grade 12. And then we have x plus 1 there. We are now factorizing this trinomial. What does the trinomial say to you? Factors of 10. When you add them, they give you positive 7. Which are those grade 12? That is 5 and 2. So for the x squared, we know just split x and x. And then to be positive 7, they must both be positive. To multiply to get the positive, yes, they satisfy the condition. Those are the factors grade 12. But remember, you are solving for x, not factorizing only. So x will be equal to minus 1 for the first one. Second one, x equal to minus 5. Or the x is equal to a negative 2 grade 12. That is how you do it. It's either you are given a factor. If it is not given, test the factor for yourself. Choose the one that is giving you a remainder of 0. Then you can now continue and factorize grade 12. Any method is acceptable. It's either synthetic, short method, or a long division method. Those are the expected x values grade 12. And then I want us to sketch a cubic function grade 12. I want us to look at the sketching of a cubic function. All right. Sketching a cubic function. To sketch a cubic function, number one, you must identify the shape. How do you identify the shape? You are relying on the equation of that particular cubic function. What is the original equation grade 12 for the cubic function? Our original is y is equal to ax squared plus ax cubed, plus bx squared plus cx plus d. That is the original function for a cubic function. All right. And then now, how do you identify the shape for this particular equation? We are depending on the value of a there. Remember, we also did that with the parabola function. Okay, if a is greater than 0, meaning a is now positive grade 12. That means we are expecting a graph that is start facing down and then upwards. Can you see the part that is ending is positive because your a is positive? Or it can be a smooth curve like that one, but the last arm will be positive there. And then if a is less than 0 now, depending on the a from your equation, meaning it is negative, the graph will face up and then down. Can you see the eventual part is facing down negative? Or it can be a smooth curve like that one, which is showing that is a negative function. And then to calculate the x and y intercept, you know grade 12. If you are calculating the y-intercept, you let x equal to 0. All right, we have already done that when we solve for x on the previous activities. Okay, and then x-intercept, you let y equal to 0. And then this one is involving factor theorem. You can't do anything without factor theorem. You need that previous factor theorem grade 12. And then going stationary point. What do we mean by stationary point? We are meaning the turning point of that particular function. But in this case, because we are talking to a cubic function, you will be having a maximum turning point and the minimum turning point. irrespective of whether it's a negative or a positive function, there will be a maximum and the minimum turning point of that particular function. That simply means now we will be having two coordinates now, which is the maximum turning point coordinate, x and y, and also the minimum. And how do we calculate these stationary points, grade 12? We are relying on the derivative. Remember, on the previous weeks, we were deriving using the first principle, deriving using the rules. Then we are going to use those rules now to find the stationary point. You are going to derive your f at x function, and then that derivative now you let it equal to 0. And then after letting equal to 0, you solve for x. After solving for x, you substitute that particular x into the original equation. Okay, your f at x original, okay, to find the y turning point values. And then it's only then that grade 12 that you can sketch that particular function. Okay, and then let's take the first example then. All right, remember now we need what? You need to identify the shape. Number 2, you need to calculate your intercept, x and y intercept. Number 3, you need to the stationary point of that function by deriving. It's only then that grade 12 you can sketch a cubic function, right? In this case, they say sketch the graph of f at x. That is the function given to us. I don't think this 0 is there. There's no way you can get a 3 there. Okay, for that particular function. And then now in this case, remember, we have indicated that you need to identify the shape. Let's see, can we do that, grade 12? Identify the shape. The shape is depending on the value of a. How much is the value of a here? You can see it's a 1. Positive 1. That means it's greater than 0. It is positive. We are expecting a graph that will be this shape or a smooth curve like that one. Okay. That is the first identification. Number 2, we are looking at the intercept, the x and y intercept. Let's start with the y-intercept, grade 12. To get the y-intercept, you let x equal to 0. If you let x equal to 0, x equal to 0, x equal to 0, this part will be 0 now. What is left is what? Y equal to 3. That will be your y-intercept. Or you can even do it on that factor, where you substitute the x0 there, x0 there, put everything into your calculator, it will still give you the same value, grade 12. All right, and then now, thirdly, let's look at the x-intercept of that function when y is equal to 0 now. Lucky enough for this expression, we are already given, for this equation, we are already given the factors. Factors are given to you, grade 12. No need to multiply them out, okay? Lucky enough, we have factors for this. But if you don't have factors, you follow the previous method of solving for x, all right? The one that we did with factor theorem, long division, synthetic, and so forth, or the short method. In this case, now we are given factors, which is x minus 1, 2 bracket of that with the x plus 3. And then this is equals to what? A 0, because we let y equal to 0. And then the first bracket will give us x equal to 1. Remember, we have 2 of them, but we will only present 1 because it's the same thing. Or the x is equals to a minus 3. And remember what I said previously, grade 12, if we have 2 brackets of the same thing, it is telling you that this x value is also an x value for the turning point. We'll verify that when we calculate the turning point of this particular function. Now, fourthly, let's look at the stationary point, which is the turning point of this particular function. Remember the rules of differentiation. It states that you cannot derive where you have brackets. Remember, there's no way we can take this equation at that level. The better part is this one, because we are avoiding brackets, grade 12. Now we are having f at x, which is equal to x cubed plus x squared minus 5x plus 3. And then derive, because we are looking for the stationary point, you derive that. That will be what? 3 times 1, which is 3. X subtract 1, that will be to the power 2. Correct? Plus A 2 times 1 there, that will be a 2. And then from 2 we subtract 1, that is x to the power 1. Okay. And then the last one, that will be coefficient minus 5. If it's a constant, still remember, it's a 0, right? Okay, therefore, this is the derived equation of that function. But remember, we said we are going to let this derivative equal to 0 now. And then now we can now factorize the right-hand side of this particular function. It is now a quadratic function. You can use what? A quadratic formula also to factorize if you are not comfortable with the bracket type method. And then this is the 3x and the x there. We are looking for factors of 5. When you subtract, give you 2. But remember, this 5 will be affected by the coefficient there, which is 3 of x squared. When you test those factors, please, grade 12, ensure that you place them correctly. So factors of 5, we know is only 5 and 1. So if we put a 1 here and the 5 there, it will not work because it will give 15. Okay? So now we are going to place a 5 here and the 1 there, so that we can add up with a positive 2. These 2 will give us 5x, and then those 2 will give us a 3x. Okay, 5 minus 3 will give us a 2. Can you see that? That means 5 must be positive in order to have a positive 2. 5 must be positive, and then this one will be negative. So this is giving us the x values for the first bracket. It will be x equal to minus 5 over 3. Grade 12, do not leave it as minus 5 over 3 because you must know actually where does this minus 5 over 3 lie on your x-axis, all right? So change this to decimals now so that you can have a specific point for that x value. So if we write this in decimal form, it will be minus 1,67. We can see that it is between 1 and 2, all right? And then the next x value is x equal to 1. After having the x turning point, you substitute them into what? The original equation to get the y values. You can use a calculator to do that. And then after substituting the first one, it will give you a 9,48. And then after substituting a 1, it will give you a 0. Can you see what I've been talking about previously? That we will be having a turning point x value because it has repeated itself at the x-intercept. This is verifying that one of our x-intercept is 1 and 0. And then the next one is minus 1,67, which coordinate with 9,48. Grade 12, that is all we need for sketching a function. Okay, right. Now let's sketch the function now. Let's sketch. We have all what we need to sketch that particular function. You are having your y-intercept there, y equal to 3. Then you on the y positive, you have your intercept. Please make a star or a dot on the intercept there. For the x-intercept, you are having x equal to 1 and x equal to a minus 3. X equal to 1, make a star or a dot there, and then the x at x equal to minus 3. That is your second intercept then. All right, and then now let's deal with this turning point now. We are having a turning point at minus 1,67, coordinating with 9,4. And then the next one is 1 and 0. Grade 12, if you compare the y values of this, you can see this one is maximum, is bigger than 0. Then this will be your maximum turning point. What does it mean? We are expecting a concave down like that. And then at 0, it's a minimum. It's where we are going to have something like that. Okay, and then let's check now. We have 1 and 0 as the turning point. 1 and 0 still at that point, okay? But we have indicated that at that point, it must be a concave up part. It's very important. This will assist you in sketching a correct graph. And then now this one of minus 1,67 is between minus 1 and minus 2. That is minus 1,67 there. This will alternate with 9 going up there. Then we have a point there. But remember, we said this is maximum. It will be concave down like that. Stationary. So you can just join this to the remaining points. Okay, so this is the expected graph of that. Please identify the maximum turning point and the minimum turning point at that level. Thank you very much, grade 12. And then, as I am about to finish with the presentation for today, can you please take this graph as your homework? Sketch the graph of f at x equal to x cubed minus 7x squared minus 10x plus 16. That will be your homework, grade 12. Thank you very much. This lesson now is about to stop. It was brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcasted by Pagama Research and Development. Thank you very much, grade 12. See you again on our next presentation. I know you were very well audience cooperating throughout. Thank you very much.